Hi guys, in today's video I'm going to be discussing Unit 8 of AP Calculus BC or AB. I'm going to be discussing volumes with cross sections and how to find them. So let me start with a key idea which you must know. So if we have two functions, f of x and g of x, so say f of x looks like this and g of x is like this. So this is f of x and this is g of x. This length between the two graphs is this length between the two graphs is, and say this is point C, it would be g of c minus f of c. This is the length between the two graphs. And g of c comes before, like it comes first because it's above f of c in this point. So now let's move on to the topic. So for a cross section of area AX taken perpendicular to the x-axis, the volume is equal to integral a to b a of x dx. So this is the area when it's taken with respect to the x-axis. And now similarly, when we have it with respect to the y-axis, so it's the same thing taken perpendicular to the y-axis, the volume is equal to integral c to d a of y dy. So these are the two formulas. So the volume is the integral with the two bounds of the area. So now let's look at a question. So we have something like this. We have one graph here. This is y is equal to x squared. And then we have another graph like this, which is y is equal to negative 2x plus 3. So these are our two functions which we have. And they're asking us to find the volume. Let me write the question. Set up the integrals. So they're not asking us for the value, but they're asking us to set up the integrals to find the volume of a solid whose base is the area bounded by the graphs of y is equal to x squared and y is equal to negative 2x plus 3. And their section are perpendicular to the x-axis. And they're asking us to find the area to find the integral for the volume using rectangles of height 4. Rectangles of height 4. So this is what they're asking for part A. So how do we go about solving this? So we're adding the areas of several rectangles that are upright to find the volume. And we know that the volume of the area of a rectangle is the length into the height. We know that the height would always be 4, right? So the area would be 4 into, let's say this distance is L. It would be 4 into L. So that would be the area of the rectangle. So now how do we find L? L is minus 2x plus 3 minus x squared. So then the area would be 4 times minus 2x plus 3 minus x squared. So 4 times minus 2x plus 3 minus x squared. So this is our value for area. So now that we got this, we need to find the bounds. We find the bounds by equating the two equations. So x squared is equal to minus 2x plus 3. We get x is equal to negative 3 and x is equal to 1. These are our two bounds. Hence, the volume would be integral negative 3 to 1 4 times minus 2x plus 3 minus x squared d. So this is our integral for the volume. So that's how easy it is. In this example, they asked us to find the volume using rectangles of height 4. Now let's look at it for a different shape. For example, semicircles. So let's say we have semicircles now instead of, one second, let me just clear this. So now part B says using semicircles. So let's just start out by writing the formula for a semicircle. 1 by 2 pi r squared. This is the area of a semicircle. We know that r stands for the radius, right? The radius is always the length divided by 2. From the last part, we already got what L was. The length was minus, so L is equal to, one second, L is equal to minus 2x plus 3 minus x squared. So the area can be also written as half pi L by 2 whole squared because r is equal to L by 2. Now we can plug in our values to find an equation for the area. So then the area could be written as pi over 8 L squared. And we know that the two bounds are negative 3 and 1. So the volume would be integral negative 3 to 1. The area, which is pi over 8 times L squared. L is minus 2x plus 3 minus x squared whole squared dx. So this is our value for the volume when we use semicircles. Pi by 8 can also be moved outside the integral to make it easier to integrate. Okay, that's it for today's video, guys. In today's video, I discussed volumes of cross sections. Hope you enjoyed and please like and subscribe. Thank you.